So, you want to make a star. In order to do that, you're going to need to get a nebula. Step 1. Grab a nebula. Assuming you plan on doing this by hand, you're going to need two things. 1. Be large enough to compress a nebula, and 2. Not be dead. Nebulas are huge, like 210 million suns huge. Since we can fit approximately 176 septillion average-sized humans inside of the sun, you'd have to increase your volume by 3.7 duodecillion times, or 3.7 with 40 zeros just to be a similar size. Next, if the average person breathes about 440 cubic feet of air per day, you'd need to bring that with you so you'd have enough oxygen to keep your body going. Sounds easy enough, just bring some in a tank, right? But creating a star takes a lot longer than a day, closer to 73 billion of them. So let's just say that we can somehow get all of that. Well, that's not taking into account the fact that you still have to multiply that by 3.7 duodecillion just to make up for your change in size. Can we just, like, imagine this, like, not actually do it? But even if you did somehow figure out a way to get that much oxygen, you'd still have to figure out a way to contain all of it, stop debris from the nebula from slipping between your fingers, and protecting yourself from the vacuum of space. Okay, so let's just use something friendly, like gravity or a supernova shockwave to get the nebula to start crunching together. Step 2.
Pizza time.
You might notice the nebula starting to spin as its matter gets closer together. This flattens it out sort of like how a pizza does when you fling it around on your finger. But unlike a pizza, which stretches out, the matter in the nebula will pack inward and go even faster. Because of gravity and stuff. Step 3. Waiting. You should let the nebula collapse into itself for a few thousand years, which should hopefully give you enough time to study for midterms. At this point, your spinning mass is called a protostar, or a big hunk of stuff with no fusion yet. It should start to look a bit like a sphere and begin to have its own balance of thermal pressure and gravity. Step 4. Nuclear fusion. By now, your protostar should have collapsed enough to reach a core temperature of roughly 10 million degrees. If the nebula you grabbed was big enough to reach that temperature, you've officially made a star. 10 million degrees, Kelvin or Celsius, means your star is hot enough to undergo nuclear fusion, where hydrogen atoms are accelerated so fast that they literally start fusing together, with every 4 hydrogen atoms combining into 1 helium atom, along with a photon and a neutron, which seems like a scam in my opinion. Like, I'd hope for at least a 1-for-1 deal, but look at how bright it is everywhere. Step 5. Disappointment. If this didn't happen to you, you're probably left with what's called a brown dwarf, or a failed star. This happens when your nebula couldn't reach the temperature necessary for fusion because it wasn't big enough. That's okay though, I'm sure it has a great personality. Step 6 kinda depends on how much mass you grabbed at the beginning, so for the sake of this video, let's assume that you got enough to make a star pretty much exactly like our sun. A star like this will last you, say, 10 billion years, but near the end things will start to change, so buckle up. Step 7. Eventually your star will start running out of fuel, and since we can't add any more mass at this point, the core of the star will start to switch to helium as its primary fuel source. 8 and 9. Not that your star is dying, things are going to start to get hot. The star will start fusing atoms like oxygen and carbon and grow to be huge and red as it eventually cools into something called a red giant, which is hilariously creative. After a few million years, the star's outer layers will start to drift away from the center since there isn't enough mass to continue fusing atoms. What you'll be left with is called a planetary nebula, which kind of looks like an eye. 10. Once the outer layers have all left, all that'll remain from your star is an Earth-sized ball called a white dwarf, which will slowly burn over the subsequent millions of years. The question now is, what should you do with this information? This list of instructions is such a niche thing, which is hilarious. I'll put that next to my WinForce 570 and my list of celebrities who are gluten-free. Okay, I don't really know how to end this video. Alright, bye.